two equations, so we're looking at two equations. There we go. And we're going to be either graphing them together or solving them together. So right now we're dealing with 2. Next week we'll look at 3 or 4 or 5. We'll switch it to an inequality instead of an equation. So we have a couple other words here. A solution. So Nick kind of said the solution. Nick, what is the solution? Yeah. And because we're graphing linear equations, it's going to be where the two lines intersect. And they intersect at a specific point. So our solution is going to be an ordered pair, not just an x and a y separate from each other, an ordered pair together. So again, that notation, putting the two together because it represents that point on the graph, the x and the y. The two other terms here describe the type of solution. So a consistent solution is a graph that intersects or has a solution. It also have many solutions as well. Inconsistent means our graph does not intersect, or our lines do not intersect. So that means there would be no solution. Why would you have two lines that don't intersect, Jack? Yeah. So these are going to be parallel lines. So a graph that has parallel lines is called an inconsistent graph. There isn't an answer, there's no solution. A graph that intersects is called a consistent graph because it has a solution, it has an answer. There's a value for x and y that we can plug into both equations and it'll hold both equations true. So if you look at the first one, it says to graph the system and then it says to estimate the solution. And then it also says to check the solution algebraically. So we have 4x plus 2y equals 4, 2x minus 3y equals 10. Cole, what do you think you would need to do first to graph these two equations? Yeah, we're going to have to get them in y equals mx plus b form. So to graph them, we need to have y by itself so that we know what the slope and the y-intercept are. So x to the other side, divided by 2, and then I have one equation. Same thing with the second one. Careful with that negative in front of the y. So take the x to the other side, and then divide by -3. So just be careful with that minus sign when you're dividing by a negative y value, a negative in front of the y. Make sure you're carrying that y value, the number in front, to every piece. So now we graph them. And you're graphing both of them on the same graph. So the first one starts at the y-intercept of 2. It moves down 2, right, 1 with the slope. enough points that your line goes in both directions. Remember, our goal is to see where they cross or where they intersect. So make sure you're making enough points that it could intersect on the left or the right of the y-axis. The next one, we have 2/3 x minus 10/3. What is negative 10/3 approximately? Chris? Yeah, so it's approximately negative 3 1/3. So go down negative 3 and then a little beyond that. This slope is up 2 and right 3. So it says graph the system and estimate the solution. Peter, where does it look like the solution is? Yeah, so it looks like the solution is at 2, negative 2, this guy right here. So to check it algebraically, it says check the solution algebraically. Peter, how do you think you check it algebraically? Yeah, plug it into the equations. Plug it into the original equations, plug it into the y equals equations, totally up to you. But you have this ordered pair, you're plugging it back into the equations to make sure it's correct. I'm going to plug it back into the original. So the original x is 2, y is negative 2. We need to make sure that equals 4. So when you're checking it into the equation, do those values equal 4? Well, 8 minus 4 does equal 4. So I would put a little check mark next to it to show that one's correct. The next one we have would be 2 with positive 2 for x, 3 with a negative 2 for y, and that's supposed to equal 10. And this is 4 plus 6. 4 plus 6 does equal 10. So the answer is at 2, negative 2. So plug it back in, check it, put a little check mark next to it because it does hold true. That's really like pretty much the only thing involved with graphing. Graph 2 lines, find where they intersect. So if you flip the page, there are a couple others. I'm going to show you how to use the calculator that we can also check the solution as well. So see if you can get these two equations to graph. So graph the system, estimate the solution, just like the last one. So get it in y equals. And then I'll show you how that calculator works so that we can kind of check the solutions in the calculator. Jack, what two equations did you get? What did you get for the first equation? negative 4x minus 2. That one's just moving the x to the other side. And then when we take the 6 to the other side and divide by negative 3, Jack, the second equation is?
Y equals 2x minus 4.
Yeah, and I think it's a negative 2x.
Oh, yeah.
So the first one starts down at negative 2, and it's moving down 4 or up 4. It's a pretty steep line. The second one is starting down at negative 4, and it's moving down 2 or up 2. And right there is the intersection point at 1 and negative 6. So if you go to your calculator, we're going to see if we can check this in the calculator. So we need to enter these equations into y equals. So that would be the first thing that we have to do. So in your calculator, go to the y equals and plug in those two equations that you have solved for y. So both equations need to go in separately, one for y1 and the other one for y2. And make sure you're using the minus sign for the 2. So a negative 4x and then the minus 2. A negative 2x and then minus 4. And then you're going to hit the graph button. And you should see the same two lines that we just graphed. So the steepness of the line should look similar to what you have graphed. Oh, 2 seconds, y equals. And then number 4. Anybody else not put their calculator in the graph? Do the same. Go back 2 seconds, y equals. So does anybody know how to use the calculator to find out where they intersect? Peter, do you know? So you could hit second table. So one option, there's a table. Right above the word graph, you see table. So if you go second table or second graph, what would you be looking for in this case, Peter? Yeah, seeing where the y value is the same. So here's x, y is the same. So that would be one way you could look. The problem is if you have decimals, it's not going to necessarily show you decimals. So that's one option. You could use the table. Veronica, what would be another?
Second, calc, and then 5.
Right. The other option is to hit the second button and then trace. Above it, it says calculate. We're going to use this a lot this year. We're going to use all of these different options that are in here. 1 through 5 we'll be looking at. So number 5 says intersect. So if you hit number 5, you should see a little blinking cursor. That little blinking cursor underneath says first curve. Well, we have a line, not a curve. Don't do anything besides hit enter. And then it jumps to the second line, which is the second curve. Again, don't do anything besides hit enter. It'll always say guess. You don't do anything with guess. That's just the calculator kind of correlating the two pieces of information we just placed in there. So essentially you're hitting enter 3 times there. And then it tells you the intersection point is at 1, negative 6. So either way works, except if it isn't at an exact x value, then you have to use second trace. So if the x value is an exact number, then you don't have to worry about it, a whole number. Okay, so go second y equals. Hit number 4. Hit enter. And then graph it again. So you might want to write yourself a little note there. So you could do second trace, which is really using the calculate button. And then it's number 5. Or you can look at the table of values. And we'll use that table of values a lot as well. So just going to the table and looking at those ordered pairs that are created. Questions? So you could always use your calculator to check any single graph. You just need to have the work to support that. But like for the quiz next Friday, you should get every problem correct because you can plug all of them in your calculator and see where they intersect. Questions? So underneath this example, there are 3 different graphs that talk about the number of solutions for a linear system. So there are 3 different cases that we could have when we graph 2 lines. And the first case is what we have just seen, where you have exactly 1 solution. So we have 1 solution because the lines intersect at 1 point. We call this a consistent system, but it's also considered an independent system. And you're going to see both of those terms in your homework tonight. Graph the system. Determine if it's consistent and dependent, consistent and independent. So a consistent system that has 1 solution, because it intersects at 1 point, is called independent. The second option would be infinitely many solutions, and we usually write this as IMS. Infinitely many solutions. Why would you have infinitely many solutions? Chris? Yeah, if the 2 equations are exactly the same, so the lines are the same as well. Your equations might not start out looking the same, but when you get y by itself, they create the same equations. So if the line, you only have 1 line drawn there because the other line is drawn right on top of it. Bless you. This is called a consistent and dependent system. And that's because your answers, both lines depend on each other for the solutions there. 1 line and the other. It's graphed the same, so dependent. So consistent and independent is 1 solution. Consistent and dependent would be infinitely many. And you can write IMS. The last option is when there are no solutions, and we said on the previous page it's because the lines are parallel. This is called an inconsistent system because there's no answer. So if there's not a solution, I can't have an x and a y that holds true to make my equation work. So that would be inconsistent. So consistent has 1 or many answers. Inconsistent doesn't have any. And that last group of problems, like I think it's 15 to 27 odd, you'll be asked to identify what type of system you have. So when you graph it, you'll then say it's consistent and dependent because it's the same line. Or it's inconsistent because they're parallel. So if you look at the next example, top of the next page, solve this system, then classify the system as consistent or inconsistent. So solve the system, get y by itself, and classify it. And you can probably tell without even graphing it once you get your equations in y equals. Probably tell what type of system you would have. essentially you're graphing one line right on top of the other line. See if you can fill in the blocks down below. Got the little lines down below. So we have infinitely many solutions because one line is graphed directly on top. So all the points on the lines are the solutions for this problem. So this is consistent and it's dependent. So if you haven't started the next one, see if you can start that next problem for part B. And again, you might be able to tell just by looking at the equations what type of line you're going to have or what type of system you're going to have. So Gavin, just by looking at the equations, without graphing it, what could you say about the equations?
Parallel.
Because,
So let's do the same.
yeah, so just by looking at the slope is the same, so these are going to be parallel. They have different y-intercepts. So the y-intercept is different. These are still parallel lines because the slope would be the same. So the one starts up at 2, and then the other one goes down to -1. So because these are parallel, the lines do not intersect and the system has no solutions. So this is inconsistent. Questions? So consistent, there is an answer. Inconsistent, there is not an answer. Consistent, independent, 1. Consistent, dependent, infinitely many. I am nice. So there was a word problem that I was hoping to get to, but because I gave out the test and kind of went through some of that with you, I'll do the word problem for our warm-up tomorrow. Your homework, again, you've got graph paper when you came in. So 3 to 27 odd, make sure you read odds, checking the answers in the back of the book. You're graphing those, finding a solution, or checking the answers with your calculator. And then 35 and 37. Volunteer to do 27 or 35, Michael and Gabby. So Michael 27, Gabby 35.